We're going to work on domain and range. And domain and range are going to be very important throughout the rest of the course. These are two things that we are going to need to know. Okay? Now, I've used some of the examples that we did when we were talking about characteristics of a function. And let's just say we were given these as different numbers. Okay? So we're going to say the table of values, say that was question 1, and they wanted us to find the domain and range. We'll say that the mapping diagram was question 2, and that the coordinates were question 3. Okay? And we're going to solve the domain and range for all of them. Now, we already know by doing characteristics of a function that these are all the same, they're just represented differently. But to write domain and range, we have to be very specific. Domain talks about all the values along the x-axis. Okay? So, we have a little graph here. Domain, we'll highlight it, is the x values. So that's what domain represents. Where range represents all of the y values on a graph. Okay? So keep those, not quite rise over run, they're actual coordinates. Okay? So let's say that they ask us to write the domain and range of the very first one. The very first one here, we have x values that go -3, -2, -1, 0, 1, 2, and 3, right? So when I write the domain for them, because that's all the information they've given me, I'm going to say the domain, and this is how we write it. You have to make sure you guys write it in this style. The domain is those exact values. So we write -3, -2, -1, 0, 1, 2, and 3. Write that funny bracket around it. That's the domain. It's all of those x values. The range, however, is a little different. Think of it like a mapping diagram. We don't repeat values. So the only range values here are 9, 4, 1, and 0. So we write it in order. We're going to write 0. Oh, let's try that again. 0, 1, 4, and 9. That's the range of the table of value question. Okay? So that's for number 1, our domain and range. Okay, question number 2, when we're looking at a mapping diagram. Domains, because they've only given us specific coordinates, it's the same idea. Our domain, we write in order from -3 up to the value of 3. If you guys notice, I know the arrows are a little confusing because we've gone over it a bit. They're going to be the exact same values. Okay? So really, all we have to write in a mapping diagram is we really just got to look at what the values are and write them out. In the table of values, we have to be a little more careful. I can't use that pen because things can repeat. We might have 2 x values that are the exact same, but we wouldn't repeat them when writing them in the domain. Okay? So, with our domain, it's still going to be the exact same thing. -3, -2, -1. Oh, that didn't work out nice. 3, 2, 1, 0, 1, 2, and 3, right?
Yeah.
Our range is going to be what?
9,
Yeah.
4, 1, 0.
Yeah, they're going to be the exact same range because we're using the exact same question. Okay? And then for question 3, is the domain and range going to change at all? No, they're the exact same coordinates. They just represent in different ways. So you have to be able to piece together the domain and range. Remember, and we'll go back to a single page here. Remember when looking at this, domain will be our x values, and the range will be just the y values. Because there's only 4 y values, we only write those 4 y values in the range. A mapping diagram is easy to get domain and range because they only write the specific numbers that are in it. And if we're looking at coordinates, we write down all of the x ones for domain and all of the y coordinates for the range. And that's how we got our answers on the other page here. But I'm going to give you something that's a little different here. Now we know that these numbers were actually part of a graph. And I drew that graph a little earlier. Okay? But when we look at this graph actually gives us a little more information than those questions have. I'm going to show you this graph here, and I'm going to show you how the domain and range change a little because of it. Our graph was at 2, 4. Okay, here's our graph. This graph, though, is not just specific values. Now, we'd written specific values before, and technically to graph them, we would just plot them. But let's say we were given this graph instead. Okay? This is continuous. Because it is continuous, the domain, we can't write every single value because there's millions of little numbers between -1 and -2. Just like there's a million different numbers when we use decimals between 2 and 3. I wouldn't write all of them out this way here. Okay? So in order to represent that it's continuous, we start the equation. Anytime we have a line that's continuous, we say x is the element of all real numbers. So what we're saying is x represents every single number, and then we give it a restriction. Well, because this graph has arrows at the end, left and right, we know it's going to go to the right forever and to the left forever. So there's no restrictions on this. The domain of this function is every single number possible. X represents all of them. Okay? So this is a little different than we'd written it before. Before we only had coordinates. Now we actually use a function notation because this is a continuous function. So because it's continuous and goes on forever, that's all there is. Now, our range. We know range deals with our y-axis, but our y-axis is continuous. So we start the range the exact same way, and I should write D here first. I apologize. Our range, well, y is continuous, so y is the element of all real numbers. But does y go below 0? No, so there is actually a restriction on y, and that's very important because we're going to have to talk about restrictions here. I need a little more room to write this. Okay? So because there's a restriction on y, what we're going to do is we're going to write a line here. And we're going to say y is every number. This line represents, we say, such that y has to be greater than. So we have to remember our greater than and equal signs. And equal to 0. So what that tells me of this function is that y is every single number as long as it's 0 and above. Which makes sense. From 0 up, this function will continue forever. But it'll never go below here. Okay, so that's why our restriction is there on this question. Okay, so let's say we're doing this and they ask us for the domain and the range. Well, we know that the domain, again, is all the x values. Well, this exists from -7 to +7. And it's every single number in between here. We can find y values, right? We can find y values for every single number in between here. Because it's continuous, we have to start the domain with xer, okay? Because this is a continuous function. But there's restrictions. X only exists between what two values?
-7 and 7.
So this is how I'm going to write it. -7, x is greater than and equal to -7, but less than and equal to the value of 7. Okay, so we write x in between those two. Just think of it like the larger thing is always pointing at the smaller. So 7 is larger than x, and x is larger than -7. Okay? So, if we do that exact same thing with the range. The range. Again, this is continuous up and down, so we're going to start it with YER. And there's a restriction. How high does it go?
4.
How low?
3.
-3. Goes down to -3. So our restriction, I'm just going to jump over the y-axis so you can see it. The lowest value is -3. We know y is greater than and equal to that. And the highest value is 4. And that's it. Y exists between those two values.
But when you say greater, you have to put that line.
Yeah, because it's equal to 2. That means it touches it. Okay? Now, One last thing before we go. This one part is very simple. If something is a function, where's the button? There it is. If something is a function, it passes something called the vertical line test. Okay? So, in order to figure out if things are a function, when you guys are given them in the table form, mapping form, all those things, I want you to plot them and draw a vertical line. If I draw a vertical line here, the vertical line can only touch the function once. So for this parabola, I'm going to draw many vertical lines. Does it ever cross through the function twice, each vertical line? They always cross it once. So that is a function. For this guy here he might only cross it once, but when he goes through at these points, how many times is he crossing this?
Twice.
So is this a function?
No.
No. As soon as it doesn't pass the vertical line test, so if it touches it more than once, it's no longer a vertical line. So let's say we even had just points on a graph. Here's a point, here's a point, and here's a point. And they wanted to know if that represented a function.
No.
Well, this one we could, but this one wouldn't. Because that one x value has two y coordinates. So in order to figure that out, if they gave it to you in a mapping diagram, just plot it on a graph and draw a vertical line. If the vertical line only touches it once, it is a function. If it touches it more than once, it's not a function. So this is not a function, and we're going to say, yes, this is a function.